Let's take a look at what atom economy is. So these questions usually come up alongside percentage yield questions in GCSE grade 9, grade 10 chemistry. Atom economy is slightly different to percentage yield. With percentage yield, it's the mass of the substance produced over the total mass expected, so the theoretical mass times 100, whereas atom economy specifically looks at the relative formula mass of the product that you actually want. So you're not actually dealing in, masses generated during the experiment in grams or kilograms. You're just using the atomic masses from the periodic table to work out what the RFM of the product is, and then you compare that against the waste product. So that's what it's referring to there. So RFM of desired product divided by the total RFM of all the products. RFM, by the way, stands for relative formula mass. And then you times it by 100. What does it mean by the desired product? Well, let's make an example up, right? So let's just say, here's a well-known process for making hydrogen. So if you combine methane gas with steam, you produce hydrogen gas plus carbon monoxide. And the way this is balanced is to place a 3 there. Let's use some different colors to highlight products that are, the desired product versus waste products. So this would be the desired product, and this would be the waste product. If we look at this statement, yes, you need to include stoichiometric balance numbers if they're in the equation. What that's referring to is when you're working out the RFM of the desired product, which in this case for hydrogen would be 1 + 1 = 2. If there's a balancing number before that, you need to include it in the calculation when you put it into the atom economy formula. So if you're making multiples of the product, that needs to be put into the formula as well. Let's take a look at a typical example. Before we start, make sure you got your calculator and your periodic table, because to work out the relative formula mass of compounds, obviously you need the individual atomic masses for each of the elements. So what is the atom economy of this reaction? The desired product is the ion itself, and then the carbon dioxide is going to be the waste. So we use the formula. So on the top we have 4 times 56, because iron has an atomic mass of 56 and there's 4 of them, divided by 4 times 56 plus 3 times, so 1 carbon dioxide is 12 plus 16 plus 16 is 44. Grab your calculator. Don't forget to bracket all of this in 1 on the bottom, and then you times by 100 at the end. Gives an answer of, so to 1 decimal place is 62.9%. So what does that mean? It means that 62.9% of the starting material, which is the iron oxide and carbon, ends up as useful product, ends up as iron. And then the other 37% is formed as a waste product, which is the carbon dioxide. So this atom economy is not brilliant, but it's not too bad. It is almost 63%. So what you should look at now is a comparison video which I've done on atom economy versus percentage yield, and how one can be completely different to the other, and actually how then sort of industry decides whether to carry out a reaction or not, depending on the percentage yield compared to the atom economy. So I hope that was helpful today, and if you had any value, please subscribe, and I will see you in the next one.